Okay, an overview of OPC. Where did it come from? Okay, originally came out of Object Linking and Embedding, Microsoft term, okay, for process control. There's our OPC. Depending on the source you talk to, currently the acronym OPC stands for Openness, Productivity and Connectivity, OPC, or Open Platform Communications, okay, again, OPC. So the scope of it is all about exchanging raw data between systems, okay? So OPC does not address hardware interconnections, and it does not address how clients and servers are actually written and implemented. OPC is about the comms between them. That's what it is as a standard. It's all about the comms. Okay, historically, lots and lots and lots of different comms, okay, at all the different levels across your plant, okay, control level, device level, information level, and up and above this to your various corporate systems, middleware, MESs, all sorts of things. All of these comms historically are different, okay, and they come from different vendors, okay, your block IOs from one vendor, your micros from another, operator from another. Everything needs to talk multiple different protocols, okay. OPC, okay, this is an attempt originally to address this, okay. So the intent was to try and get a common protocol that all of these things could talk. So data sources in the OPC space, now we're talking about things like standard computers, talking to databases, talking to PLCs, talking to distributed control systems, okay, talking to standalone P&ID controllers, and also remote terminal units. The intent was all of these things could provide raw data, okay, and then that data could be consumed by clients elsewhere in the system. So OPC is all about communications. The other problem we have, if you cast your mind back to things like the Modbus standard, which only understands 16-bit integers, okay, there is a lot of different data formats out there. One of the other things that OPC sought to address was to allow systems to communicate all of these different formats across the communications infrastructure, okay, and have both ends understand what was being provided and how it was configured so that they knew what to do with it when it arrived at the other end, okay. It's all about, again, you know, the problem we have is how does one person implement, you know, a double floating point number? It might be different to another vendor, okay? And that's in fact the case if you look at things like Modbus. OPC was all about trying to tie this down to make one standard that would allow people to pass the information across the network so that both ends of the pipe understood what was intended by that piece of data. So, again, there's lots and lots of users of data out there, okay? There's HMIs, there's SCADAs, okay? There's trending devices, there's archival users, okay? ERPs, resource planning type systems, okay? There's historians out there, there's condition monitoring stuff, okay? Might come out to operator interfaces, trends, alarms, controls. There's lots and lots and lots of different people out there and different devices out there that are interested in the raw data, you know, especially today with things like, you know, Internet of Things and sensors everywhere, okay? Everybody wants access to the data. So, yeah, this is one of the other problems that OPC was hoping to address. If you make one communication standard, it doesn't matter who you are. If you understand OPC, potentially you can get that data from whoever is providing it. Okay, the other thing, okay, different interconnections out there, point-to-points, okay, lots and lots of different sorts of point-to-point links, you know, fiber, serial, you know, 900 meg links, gigahertz, microwave links, all sorts. There's multi-drop buses, okay, we've got, you know, DMP3 and DF1, you know, and, you know, Modbus and protocol space. We've got all sorts of different networks out there, okay? Ethernet, Profibus, Foundation, dozens and dozens and dozens of field buses, Okay, and again, there's a huge number of different operating systems out there at the server side. Okay, and again, they vary massively. So, again, huge landscape, many different protocols and different connections in the industrial communication landscape. So, if you've got an industrial control space, okay, we've got three devices here. We want an operator looking at an HMI. Okay, we're archiving the data so we can make decisions about it, and we've got a machine monitoring system, okay, looking at maybe vibration or bearing temps or something like that. Again, three independent control systems, a PLC, some measurement up here, and a performance calculation engine. Okay, vendor supplied, it might be a GE thing looking at your train prime mover, for example, doing performance calcs on it to optimize the diesel use, those sorts of things. So, again, you've got machinery in the middle here, okay? Could be a turbo generator, could be all sorts of things. So, historically, okay, the HMI would have had to have three separate pieces of software written to talk to the three different devices out there in the field. Okay, and that would be the same for each of the things. Okay, so each of these systems, if they're proprietary, would have to have a bunch of coders writing drivers to talk to everybody else's proprietary interface. Okay, this is the way that it used to be. It's getting better and better. Okay, the intent of going to OPC was that each of these three devices on the bottom would have an OPC server on it, and then all the devices, okay, up on the top would have an interface that could just talk to any of these devices as long as they implemented the OPC server in a standards compliant manner. So the intent was, instead of having lots and lots of proprietary drivers, there would be one way to pull data up from the floor. Okay, so that's where it's come from. Okay, now OPC runs in what's termed a logical object model. We'll touch on the object-orientedness of it as we go along. Okay, an OPC client, it's a classic server-client or client-server relationship. Okay, our client, we want data. The devices in the field, they're servers. It doesn't matter who they come from, vendor A, B, or C. Okay, they all should implement the standard appropriately. So any client can talk to any of them. Okay, so the client talks to the servers and gets data over the network. Now, down at the software space, okay, it's going to look something like this. Okay, this is a nice pretty picture over here. This is what happens. Okay, in the software coding space, it's going to look something like this. Okay, now each instance of a server is going to be written in software. Doesn't matter what that code is on the inside, as long as the interface, okay, in this space here is implemented according to the standard. It doesn't matter what the code is on the inside. Okay, so it could look like this. They're all objects. Okay, we have a SCADA system up here. Okay, it's got some physical I/O. This might be a device net interface coming in. Okay, it presents the data it gets from the physical I/O over an OPC interface. Okay, again, this OPC server here might have its own physical I/O connected. It might come in over, direct cards straight into the back of it. Okay, it aggregates all of this information, its own physical I/O plus its own OPC interface, and presents it out on an OPC that our HMI or historian or something else is consuming. Okay, so everything's treated as an object. Okay, it's all client server in the OPC space. So there is a more complex relationship in the OPC client and server. You'll see as we work through and build up, this server is at the top level. If you had 20,000 I/O points, okay, in your OPC server, then you're going to want to split them up somehow. Okay, so there is a level underneath that that's called groups. So you can have channel 1, channel 2, I/O card 1, you could call them processors. There's a whole raft of different ways to separate them up as groups. Okay, it's just a handy way of giving yourself a more understandable address space. And then inside each group, you'll have items. These will be the actual things that have values inside them. So as we work through OPC and work through some of the examples and the practicals, this should make sense to you. Okay? These groups, they're configurable. Okay? You can make new ones. You can regroup things. You can add stuff. Okay? You can move it around. So, again, you'll note over here, OPC/COM interfaces. We'll get into where that comes later on in this little session. Okay? COM, Component Object Model. Okay? Says relatively new, compared to Modbus, everything is new. Okay, the first generation standards are all based on Microsoft's DCOM technology. Okay, and later OPC XML DA is the next level up of it. Okay, so the original OPC spec is the OPC DA, the data. So this one down here. This is the original, what most people think of as OPC. So these are all of the different specifications that are out there for the comms. So you've got historical, you've got specs about complex, data exchange, we'll get into that in a while, alarming, okay, later version of data access, we've got some common stuff, we've got batch information, again we've got security. So there's a whole raft of different standards. These original first OPC standards, the first generation ones, are all based on Microsoft's DCOM. So this is where lots of people originally went, OPC is only a Microsoft thing. It's because it was based on the Microsoft Distributed Component Object Model. So we'll get into the details of that shortly. Okay, that was the first level. What's being produced out there now is what's called UA. Okay, and the UA spec is the latest and greatest. So UA stands for Unified Architecture. Okay, so this is the list of standards, and you'll see these are now starting to be delivered out there. Have been for the last couple of years. Okay, they're starting to make their way out into the space, into the commercial space. UA is about shifting away from being Microsoft-centric. UA is very much based purely on IP. It's also updated to understand security certificates and be designed to run in a secure manner, over the open internet, and get away from a bunch of the issues that were inherited from the Microsoft DCOM approach. So just be aware, these are the standards for UA. So it stands for Unified Architecture. Again, you'll notice pretty much the same. Okay, data access. Okay, historical access. All of these same sorts of words. They do the same things, just a different communication protocol specification. Okay, OPC gets most of its design from object-oriented programming approach. Okay, so you'll see a whole bunch of this going on. Okay, so it talks about methods and classes and objects. Okay, don't be frightened of these things. Okay, they're not particularly complex. Okay, and we'll work through these briefly. So methods provide computer instructions, and the class object characteristics provide relevant data. The user communicates with objects, okay, and they communicate with each other using messages between well-defined interfaces. Think of them literally as, if you wanted to break it down, each object is like a PLC, and the software interfaces are literally like a well-defined piece of serial cable going between the PLCs, except it's all in software. That's all it is. Okay, each object is a piece of code that does some stuff, and the interfaces are just well-defined things so that each piece of code knows how to talk to the other pieces of code. So in this place, you can define subclasses of the data that share some or all of the main class characteristics. So an object, often referred to as a class. Okay, the benefit of breaking it down into objects is you can look at each one, and you can secure each one really, really tightly. Okay, and all the information about that particular object is kept with that object. Again, avoids unintended data corruption. You don't have shared memory. Each object's got its own chunk of memory and storage. When you define a class, okay, which is what an object gets instantiated from, okay, you can make lots and lots of them. Okay, you can reuse it. So you can have lots of DA servers stood up that are doing different things, but they are in all respects identical to each other, except for the configuration of each one. They might talk to different other boxes. So, classic example of an object-oriented programming language is C++. Okay, and C# and a whole bunch of the other ones. So we talk about objects. Okay, an object is a box. Okay, receives and sends messages. You do not need to look inside it. Okay, you don't need to know what the program has done. You just need to know what it does. Okay, the box contains code and data. Okay, everything it can do is represented by the interfaces to the outside world. Okay, you do not need to know anything about it in order to use it. Okay, so when we're talking about client server, a data access OPC server is a bit of code that's got some methods that you use to talk to it, to get information out of it. Okay, you want to know about the data inside it, it's got a nice message interface and you say, tell me about this please, so it does. Fairly simple. Okay, when we talk about components, a component is an identified chunk of a larger program or a construction. Okay, it provides a function or a group of related functions. So a component test means we test all the related modules that form it up to make sure they work nicely together. So if you see people talking about a component test, that means we're checking this piece of software and all the bits associated with it does what we expect. Okay, a system is divided into components that in turn are made up of modules. A component's a reusable program building block we can combine with other components in the same computer or others on a network. So, containers, things that are, a container holds a component. So a container is going to be something like a page on a website, a web browser, okay? Firefox is a container. Word, Excel, they're all containers, okay? The Windows desktop is actually a component that's a container that contains the desktop, okay? And it's got well-defined interfaces that you can get it to do stuff, okay? That's how programmers manipulate, File Explorer windows. There's methods, there's messages they can send to and from it, okay? So, exactly the same as OPC servers and clients. Everything else in the Windows space is literally, a component in a container that you can talk to. Okay. So, component interfaces. Okay. So they all have interfaces on the outside. They've got specific ones that allow you to say, "Hey, what do you do?" Okay. So let's talk about exposure and discovery. One component can interrogate another one and say, "Who are you? How do I talk to you? What are your characteristics?" Okay. So again, the properties allow a component to make its characteristics publicly visible. Say, "Yep, this is what I do." You have event handling, okay? If something blows up, it can tell anybody that's talking to it that there's been an issue and that you need to be aware that something's gone wrong. Persistence mechanism, okay? This means things like your word processor, it's a component, okay? It's a COM object, okay? You can save the configuration of your word processor so that when you open it next time, it looks as it did when you shut it down. Okay, with data and comms for process control, if you've got particular settings on your alarming or some of your trending type tags, or you've got filtering, then you don't want that to go away when that server shuts down. Okay, you want it to remember it so that when it starts back up, it's as you left it. Okay. So that's all the persistence mechanism means. It remembers how it was set, or it remembers some of the data potentially. Okay, it's got some support to let developers build it and make new ones. And again, we can package them up with all the bits that we need so that they work. So ActiveX and ActiveX Control, that was something that Microsoft called a whole bunch of object-oriented programming technologies and tools. Pretty much gone. You may see it muttered around. There was support available for most things, but it's all sort of morphed over into .NET, which I see recently has now been open sourced into the Linux space as well. So very, very interesting things afoot in that area. So this gets us down into servers and clients. Okay, server is a program that provides services to other computer programs. Could be on the same machine, could be on remote machines. Okay, don't think of a server as a computer. A server is a bit of software that provides services to other pieces of software, local or remote. Okay.